Hi everybody. Just wanted to give you a brief rundown on the LiDAR based cars that I've seen so far. This one's almost $300, so I think that we can get the prices way down for something like that. One of the things I noticed here is they've got sonar sensors, one, two, three, four of them, maybe five, six of them, so they can avoid bumping into stuff. But at the same time, they're using the LiDAR system mounted on top to attempt to map out the area around them. I think we can do our whole navigation system with a much less expensive car. Just thought I'd give you a brief rundown on how to use a continuous servo with a little wheel and an Arduino. What we're doing here is we're using the Arduino motor shield, which is directly mounted on the mezzanine bus of the Arduino, and we put it right on top of the Arduino mezzanine bus, and it lets you vary the speed and direction of the servo. Pulse width modulation is used for driving the servo. The larger the number, the slower the turning value, and so here we are starting at a relatively low speed and going to an extremely slow speed in increments of 1. This is in milliseconds, and then we go from 253 all the way down to 150, so we start from the end point on the for loop, and then we proceed to decrement until we get to the beginning of the next for loop. Here we are with a balance spot using just two wheels and then a small ultrasonic sensor. I think we could get a balance spot like this, or perhaps one with a caster that simply uses continuous servos.
In operation. LiDAR is similar to radar, except instead of using radio frequencies, it determines distances by measuring the time taken for an infrared laser beam to bounce off a target and return to the detector. My goal was to use a LiDAR detector to create a three-dimensional map of a room. To do this, I needed two servo motors to scan both horizontally and vertically. I wired up the Arduino to control the servos and to read distance measurements from the LiDAR detector. I also used an LCD panel with buttons to provide a rudimentary user interface. The Arduino steps the servo motors 1 degree at a time, then takes a distance measurement with the LiDAR detector. The Arduino does calculations to determine the XYZ coordinates of the point in three-dimensional space and outputs the data serially to a desktop computer. A processing sketch running on the computer receives the coordinates and displays them graphically. This video has been sped up. The actual time to complete the scan is 10 minutes. We can now rotate our perspective to see the three-dimensional data, called a point cloud. Most autonomous cars use a spinning LiDAR detector, allowing them to scan at a high rate to map obstacles in their path. I was impressed at how easy it was to wire up this project and get it working without much difficulty. Hopefully this inspires you to attempt your own Arduino project. Thank you.
In this video, we're going to make a small 3D printed LiDAR sensor powered by an Arduino. As you can see, it has a miniature rotating head.
Today in the workshop, we'll be working with LiDAR. IACTLidar, that's an amazing device, and the obvious LiDAR may seem like a very new technology, and that's because we see it in self-driving cars, and that's a very new technology. But in actual fact, LiDAR
What we have here is a relatively inexpensive single-point LiDAR. This can be sped up with a rotating mirror. Rotating mirror LiDARs are available, but they're quite a bit more expensive. Here's a rotating LiDAR system. This can rotate at about 400 RPM, that's the slow speed, and it will allow you to scan your entire environment very quickly.